All right, so this video is basically to accompany this blog I wrote earlier about building a minimal EDR. The idea was not to build a prediction gate EDR on either a very complex persistent system, just a simple code that showed you how detection works on endpoints and how we can use MITRE to build this. So the idea is very simple. As I've explained in the blog as well, but let me walk you through it again. So we're going to use this sub technique from MITRE and we're going to block this because PowerShell is one of the many uh, techniques that adversaries use. Is a very famous technique, as you can see from this procedure list. Many campaigns, many groups and softwares already utilize this technique. So what we're going to work with is basically the detection column right down all the way below. So MITRE basically gives you a detection strategy for every sub technique. And in this detection strategy, you can see the log sources that you're going to use. Since we're talking about these log sources here, we need to get these event codes from Windows event logs and detect if they're being used and look for further metadata and block these as well. So it's very simple. You install sysmon, you enable PowerShell logging, and you basically listen for these events, right? So that's what we did in the code as well. We basically made the AI write some code. But basically we're looking for event ID ones in our window event logging system, and we're making this process persistent that we will keep looking for these logs again and again every time. And the timeout is 0.5 seconds. So after every half second, it's going to look for more Windows logs generated for event ID 1. So the code here is very simple. One more thing I would like to walk through is the test cases that we're using. We're using three test cases from this Atomic Red Team repo. One of them is about using XML browser request. It's an XML request from your PowerShell system that downloads a file and runs it in the memory. Another one is uses a command alternative. It uses -c to run a command in PowerShell. We're going to try to block this as well. Another one is where it uses -e or -e to pass encoded commands to the PowerShell process. In this way, we can also fool a system that is not running any harmful command if the EDR is blocking it. But since we know about this test case, we can block this as well. And some other use cases that I decided from research as well is that we should not be PowerShell should not be launched through unexpected parent processes. What does this mean? This means that PowerShell should only be launched through Explorer process, explorer.exe process, because this means that you're launching PowerShell from a system like this. If it's not launched like this, this means that PowerShell is either launched from CMD or from other processes like macro, Excel macro, maybe PDF macro or something like that. And then the other two use cases are very personal to me. I've observed these in my experience in cybersecurity that set execution policy is also utilized by a lot of people in the company to bypass some precedents or some guardrails set by the administrator for PowerShell processes, and install module basically installs some external modules that you do not want to allow on the system. Okay, so the idea is very simple. Look for event logs that match event ID 1, and then see what the process is the system is executing. So if you look at the driver code, the code is very simple. If we're looking for anytime PowerShell is executed on the system, and if its parent is not explorer.exe, then we're gonna print an alert that process was not launched from Explorer, which means it fulfills our criteria that this is not this is launched non-interactively and it should generate an alert. And similarly for all the instances of PowerShell, we're gonna also look for where is the HTTPS URL pass, which means it's looking on the internet for some files, downloading some files. And other than that, we also have some command flags that earlier mentioned. These are not exhaustive, but a way of blocking command flags. This is encoded flags, which basically blocks any encoded commands passed to our PowerShell system. Okay, so let's actually demo this to you as well. What I have done here is uh, I've enabled I've ran a command prompt using administrator rights. So I have the rights to query into Windows event logs. Test.py is my file. When I launch this code, it will basically also bring some other PowerShell logs that are already in my system, and I was testing these, so we can ignore that noise as well. When I run python test.py, okay, so this now is listening for Windows event logs related to event ID 1. So let's try to launch PowerShell now. Since we're launching PowerShell through Explorer XZ, this is normal. If you look here, we get an alert that PowerShell detected. PowerShell was launched and the parent process was Explorer.exe. This is normal. We can do that. So let me launch PowerShell through CMD. You can launch PowerShell through CMD using PowerShell.exe, PowerShell.exe, and let me pass command as well. I think yes, right host ABC, and let's see if our system worked for that. Okay, so maybe it got stuck somewhere, but initially, but it came back on immediately, and it gave us the alert as well that PowerShell was launched from cmd.exe process. Again, we get the same alert, PowerShell process not launched from Explorer, and we get the command as well. So this is a good way of good way of understanding how detection systems are built. If I keep on doing this exercise, we can also block other use cases as well. Something like that I mentioned earlier here is that we can block HTTP flags, we can block command flags, we can block encoded flags as well. And if I can show you this a simple manner, if I run PowerShell.exe and and use the command flag and I pass the encoded string, I built encoded string here. This translates to basically our right host, an obfuscated way of saying hello PowerShell. And if I paste it here, let me see what I'm doing wrong. PowerShell.exe. Let me just use atomic team as a reference for this exact use case. Okay, so we're gonna pass an encoded command using -e. I'm gonna paste it here, and this prints hello from PowerShell. So basically, pass encoded command to PowerShell, and if your detection engine or if your rules are not configured to detect -e flag, then you're gonna miss this a lot as well. Let's see if our system detected this, and it got it as well. It said alert encoded PowerShell command detected. That's a good start for us. So we can see how simply just monitoring a process and all its metadata can increase your detection capabilities as well. Let me walk you through another code as well. So I separated the Windows Event ID 1 logs, which I mentioned here, from the PowerShell logs. So I built basically two Python files, one that works with event code 1 and one that works with the event codes mentioned here for command execution in PowerShell. So we can see. So if you're curious, you ask this question that okay, we can see PowerShell being launched, and we can see the command that PowerShell is being launched with as well. But what if the attacker launches PowerShell and is able to run commands inside this shell as well? Can we see that? No, we cannot see that using sysmon. For that, we have to use this PowerShell event codes to get what command was executed inside PowerShell. So for that, I have a separate code. I wrote test.py. It basically looks for event ID 4104 and sees what PowerShell command was run inside this code. And I have placed some simple if-else commands where I'm looking for a set execution policy in invoke web request, download string, other things like that. So let me launch PowerShell for you guys. And let me start this Python file as well. Let's terminate this one. Let's run another one. Python test.py. So now we are monitoring for commands executed inside PowerShell. These are some logs from earlier, but we'll try to run some commands here. We'll try to do right host ABC, and you'll see this comes here, right host ABC. So now using Windows Event ID 4104, you can even detect what kind of commands is the attacker running inside PowerShell. Or I'm saying attacker, but it can be any internal employee as well. So this basically shows how a simple how exhaustive, how helpful the MITRE list really here is. Using these event IDs, we've basically encapsulated a majority of the PowerShell attack vector. We can see PowerShell shell being launched, and we can investigate all the commands inside PowerShell as well. Obviously, if you scroll down, you have some more work to do as well. And the security never stops. You have to keep improving your processes, and you have to monitor for everything as well. But the idea you get is very simple. And you can further improve your MITRE knowledge by working with the mitigations here. You can see how the things are mitigated in your environment as well. Once you move forward from detection, you have to work for mitigation as well. And another